All right, this is a lesson to do with rational zero theorem. So let's do some vocab and some introductory work, and then we'll practice it. So recall that a polynomial, a function of degree n, can only have at most n real zeros. Now, that means the degree, your real zeros can't be more than what the degree is. Now, real zeros can be rational or can be irrational. Real zeros are those that can be written in the form of a fraction. So a rational zero can be written as a fraction, and it's a number you know exactly on a number line. What's 1/2? You know where it is. An irrational number, you can only estimate where it is on a number line. That makes them different. This irrational is a decimal that goes on forever, doesn't repeat, and you can only round it to know where it is on a number line. So we're going to use what's called the rational zero theorem. Sometimes we'll just shorten it up as RZT. What the rational zero theorem does is it takes all the factors of the constant, the last one. So the very last number, you're going to do all the factors of the constant. You're going to do all the factors of the power, the factors of the coefficient of the power term. And you are going to divide those numbers and do all combinations of P over Q. So this rational zero theorem is used as a way to factor higher order polynomials when we have no other tools at our disposal. So this gives us another tool to use to be able to factor something that has a high degree to it. Okay, number one, let's start. So we're just going to list all the possible rational zeros. So first we recognize P, which is 2, the constant. What are all the numbers that go into 2 evenly? All the factors. And it's going to be both positive and negative. So positive -1 and positive -2. Q, what's the leading coefficient? Well, I don't see a number, but that means it's 1. Then the list is all combinations of P over Q. So 1 divided by 1, 2 divided by 1. That is the list. And that, what we just did, was using the rational zero theorem to create a list, and later we're going to test that list using synthetic division. All right, number 2. We're going to now use the next thing of the rational zero theorem, that if the leading coefficient is 1, then all I need is the constant. So I don't need to divide, because dividing by 1, it's not going to change the numbers. So the list are just all numbers that go into 18 evenly. So 1, 2, 3, 6, 9, and 18. Make sure they're positive and negative. Number 3, notice the leading coefficient is not 1, so I do have to write it out. So for P, it's just 1. For Q, that's the leading coefficient. What are all the numbers that go into 4 evenly, which are 1, 2, and 4? Then the list is dividing. So 1 divided by 1, 1 divided by 2, and 1 divided by 4. Those fractions are rational numbers still. You know exactly where they are on the number line. Number 4, again, the leading coefficient is 3, so I do have to write it out. So I have 1, 2, 4, 8, and 16. What are all the numbers that go into 16 evenly? Now 3. What are all the numbers that go into 3 evenly? Just 1 and 3. Now this is going to be a long list, so it's going to take 2 rows. We're going to do all combinations of P over Q. So 1 divided by 1, 2 divided by 1, 4 divided by 1, 8 divided by 1, and then 16 divided by 1. Then we have to do 3. So 1 divided by 3, 2 divided by 3, 4 divided by 3, 8 divided by 3, and 16 divided by 3. If this function has a rational zero, it will be on this list. Number 5. Again, the first thing I look for is the leading coefficient 1. It is not, it's 6, so I need to do the work. So first, recognize the constant, 12, and it's positive and negative. So what are all the numbers that go into 12 evenly? So write down all the numbers that go into 12 evenly. Then Q, is the power term. What's the coefficient? What are all the numbers that go into that evenly? So 1, 2, 3, and 6. Then it's all combinations. Again, this will be a long list, so it'll be 2 rows. 1 divided by 1, 2 divided by 1, 3 divided by 1, 4 divided by 1, 6 divided by 1, 12 divided by 1. Then I do the same thing and divide by 2. Now, if a number repeats, I don't put it back on again. So 1 divided by 2, but 2 divided by 2 is 1. It's already on my list. 3 divided by 2, not on my list. 4 divided by 2 is 2, on my list. 6 divided by 2 is 3, on my list. 12 divided by 2 is 6, on my list, so I don't write it down. Next, I go to 3. So 1 over 3, 2 over 3. 3 over 3 is on my list. 4 over 3. 6 over 3 is 2, and 12 over 3 is 4, already on my list. Last one, I use 6 as a denominator. So 1 over 6, 2 over 6 is a third, 3 over 6 is a half, 4 over 6 is 2/3, and then 6 over 6 and 12 over 6. So the list is now complete. All right, one more time. Number 6. All the numbers that go into 24. 1, 2, 3, 4, 6, 8, 12, and 24. Great practice with your times tables. Q is 2, so it's just 1 and 2. So P over Q again is going to be a long list, so we'll do the 2 rows. So divide everything by 1. So when you divide everything by 1, it stays the same. And then the next one we divide by 2. So 1 divided by 2 is 1/2. 2 divided by 2 is 1, so it's already on my list. 3 over 2. And then 4 over 2, 6 over 2, 8 over 2, 12 over 2, 24 over 2. All of them are already on my list. So now that is a complete list of possible rational zeros that could be in this function. All right, turn the page. Now we're going to go through the steps of how we use the rational zero theorem to completely factor it and to write down the zeros. So step 1, notice the leading coefficient is 1 and the constant then we can just go to create our list. So our list using the rational zero theorem will be positive -1, positive -2, positive -4, and 8. And we can go right to it because the leading coefficient is 1. We're then going to use synthetic division. If one of these numbers is a 0, when I divide, the remainder will be 0. And then it will allow us to factor further. So the first thing I always say is, you know, one trick is, because there is no easy way to get through this list. You're going to have to guess and see if it's right, and if it's not, you move on to the next number. But some things can help you. If I write down 1, 3, -6, and -8, and add it up, if it adds up to 0, then positive 1 is a 0, and I'll use it. If it doesn't add up to 0, I'll skip it. So positive 1, it does not add up to 0, so I'm going to skip positive 1. And then I'm going to go to the next number on the list. So I'm going to go to 2. I don't know if 2 works until I actually do the synthetic division. So I'm going to add and multiply all the way across. And notice the remainder is 0. Yay! I'm done in terms of doing synthetic division. What's left over is x squared plus 5x plus 4. That factors to x plus 1 and x plus 4. So now I have all the factors. So positive 2 is a 0. That means x subtract 2 is its factor. Then we have x plus 1. Then we have x plus 4. The zeros then would be positive 2, -1, and -4. I'm not writing down the multiplicity right now. I'm not graphing it. I'm just knowing, can I factor it, and can I know the zeros? Number 8, leading coefficient's 1. So I'll go right to the list, all numbers that go into 20. Make sure I don't miss any. Then I'm going to do synthetic division to test that list. So 1, 0, -21, and 20. the first thing I'm going to do is add these up. If they add up to equal 0, then I know positive 1 works. And guess what? It does add up to 0. Positive 1 works. So I'm going to use 1. And then what's left over is 1x squared plus 1x take away 20. Now that factors positive 5 and negative 4. So now I can write down the function in factored form. So positive 1 works, so it's x subtract 1. And we still have x plus 5 and x plus, or x take away 4. The zeros then, zeros and factors are inverses of each other, so we're going to have positive 1, negative 5, and positive 4. Those are the values that make the function 0. Again, and of course you can press pause if it's going too fast and so on. So let's try it again. Number 9, the leading coefficient's 1, so I go right to 18. So 1, 2, 3, 6, 9, and 18. I do a synthetic divide sign, and I put 1, 3, negative 7, negative 27, and negative 18. I first add. Does this add up to 0? No, so positive 1 does not work. If I try positive 2, I already know it doesn't work. You don't know. You would have to put 2 and see the remainder is not 0. But I don't want to waste your time. The one that does work in this is positive 3. So I'm going to use positive 3. Again, the only way to know that is by actually doing the work. And if the remainder isn't 0, then you try the next number on your list. Now I got to do it again. One of the hints I gave in class is if all the signs are the same, then there's no more positive numbers that will go into it to give you a remainder of 0. So instead, I'm going to pick a negative number. So I'm going to pick negative 1. And what I'm left with is 1x squared plus 5x plus 6. So that factors to x plus 2, x plus 3. So now I can completely factor it. So positive 3, the factor is x subtract 3. Negative 1, it's x plus 1. And then I have x plus 2 and x plus 3. So that means the zeros are 3, negative 1, negative 2, and negative 3. 10. What makes number 10 different is I have a number that's not a 1 in front. It's a 2. So when I think through my list, I have positive, negative 1, 2, 3, and 6. So when I divide by 1, they would all be there. Now if I take those same numbers and divide it by 2, I get 1/2. 2 divided by 2 is still 1. 3 divided by 2. 6 divided by 2. So those are all the numbers. So if there's a rational 0, it'll be on that list. So I'm going to do a synthetic divide sign. I have 2, negative 5, negative 1, and 6. Now it does not add up. It does not add up to 0, so positive 1 doesn't work. So I'm going to go to the next number on my list. And again, if this didn't work, you go to the next number on your list. So I have 2x squared, subtract x, subtract 3. Now that's a quadratic I can factor. 2 times negative 3 is negative 6, negative 1 underneath. So the two numbers that match are negative 3 and 2. So I'm going to go back here, go 2x squared, subtract 3x, plus 2x, take away 3. I'm going to factor by grouping. So the first two have an x in common. The next two have a 1 in common. And now you factored it. So they have a 2x subtract 3 and an x plus 1 left over. So what is it completely factored out? So 2 gives us x subtract 2. And then we have 2x subtract 3 and x plus 1. So what are the zeros then that come from there? So positive 2, positive 3 over 2, and negative 1. And notice these numbers are all in our list. So again, if you tried a number and if it doesn't work, you go to the next number until you find the remainder 0. All right, turn the page. 4 and 15. So we're going to start with 1, 3, 5, so 1, 3, 5, and 15. Now, over 2, so the factors are 1, 2, and 4. So I'm going to take all these factors over all the factors of 4. So 1/2, 3 halves, 5 halves, and 15 over 2. Then over 4. So over 4 would be 1/4. Now 3 over 4, 5 over 4, and 15 over 4. So those are all the that's a long, long, long list. So I definitely do not want to be able, I want to find something quick. I don't want to go too deep in this. So let's see some hints I can give you. So first thing I notice, it obviously does not add up to 0. They're all positive. So because all the signs are the same, there are no positive zeros. So I'm going to start with negative 0. So I'm going to start with -1 and hope that it's good. I'm not going to start with fractions. So I'm going to start with -1. And -1 works. Awesome. So what I'm left with is 4x squared plus 17x plus 15. So to factor this, 4 times 15 is 60 and 17. And I need to think of two numbers that multiply to 60 and add to 17. So not 10 and 6, not 4 and 15. What am I missing? So 4 times 5, 15 is 19. 10 times 6 is 16. 8 doesn't do it in terms of what's happening. Come on. Think, think, think. I feel like Winnie the Pooh here. What are the two numbers that multiply to 60 and add to 17? Oh, that I did it right. Did I do it right? Yeah. So 3 and 20, no. 4 and 15, no. 5. 5 and 12. All right, don't give up. So 17 is 5 and 12. Then the first two terms, they only have an x in common. The next two terms, they have a 3 in common. And then they share 4x plus 5, and what's left over is x plus 3. Remember -1? That's x plus 1. So now you have everything factored out. So then the zeros would be -5 over 4, -3, and -1. Number 12, we're going to create our list, all the numbers that go into 10, and then over 3. So the same numbers, but over 3. Now I'm hoping not to use these fractions at all. So let's factor it out, or let's do synthetic division. 3, -8, -33, and -10. So does it add up to 0? No. But there is a sign change in there, so there's a positive number that works. So you keep trying until you find the remainder to be 0. So I'm going to pick this one because I just know. But you don't know, so you'd have to keep trying until it works. So 5 works. So I'm going to write down 3x squared plus 7x plus 2. So when I factor this, 3 times 2 is 6. See, this one's a lot easier. 1 and 6. So 1 and 6, and then factor. So when I factor this, that's a 2. All right, so I factor out an x, and I have 3x plus 1. I factor out a 2, and I get 3x plus 1. So I have 3x plus 1. I have x plus 2. And then 5 is x subtract 5. So you've now factored it, and then the zeros would be -1/3, -2, and +5. One more time. 13. All right, 30, 1, 2, 3, 5, 6, 10, 15, and 30. So there's your list. I'm going to do synthetic division. I'm probably going to do it more than once. So 1, 1, -31, -61, and -30. Does not add up to 0, so +1 does not work. So one of these numbers, so I know positive 6 works, but you'd have to try it until it does work. And as soon as you see it doesn't work, cross it out and do the next one. Don't have to finish it all the way to the end if you know it's not going to give you a remainder of 0. So negative 1 also works. So that leaves me with a simple trinomial. So that's going to be x plus 5, x plus 1. So when I write this out, be careful here. See that 6 is easy. That's x subtract 6. Negative 1 is x plus 1, right? But we also have an x plus 1 here. So together there's 2 of them. So we're going to write it as x plus 1 squared. And then we have an x plus 5. So we only really have 3 real zeros, but one has a multiplicity of 2. So the zeros are 6, negative 1, and negative 5. All right, start with your list. It's always best for you to try it first, but if you really can't, then you can practice with me. So what are all the numbers that go into 16 evenly? Let's draw a synthetic divide sign. 1, negative 1, negative 12, 28, and negative 16. Now, I can see that if you add this up, it adds up to 0, so I know positive 1 works. Now, positive 1 won't work again because it doesn't add up to 0. So instead of positive 1, I'm going to go to the next number on my list, so I'm going to go 2. And then what's left over is x squared plus 2x subtract 8. So when you factor it, it's positive 4 and negative 2. So now we have everything we need. So positive 1 is x subtract 1. Positive 2 is x subtract 2. We have another x subtract 2 here. So we're going to square it because we have 2 of them. And then x plus 4. So that means the zeros are 1, 2, and negative 4. So that was practicing the rational zero theorem. Can you create a list? Can you test the list using synthetic division? If the remainder is 0, it's a 0. And then what's remained, you might have to keep testing the list until it's a quadratic and you can factor it a different way. All right, the last sheet is a homework sheet, so I'm going to do that as a separate video. Mr. G Math, over and out.